Hello everyone, welcome to the next lecture on the numerical analysis. Today we will discuss about Newton's divided difference formula. I will explain you this lecture with the help of the 10 examples so that you can learn it very well. Myself Dr. Harish Garg. You can simply follow my YouTube channel Dr. Harish Garg, where you can find the various lectures. You can see the playlist of the numerical analysis in my YouTube channel, where you can find the various lectures related to this numerical analysis as well as numerical method. So we have already described the system of the equations like Jacobi, Gauss-Seidel, Lagrange eigenvalue power method, as well as the Lagrange interpolation and Newton forward method. So today we will see about here. So what is the interpolation is? The objective of interpolation is, if you have the data set x and f, or you can say y is equal to fx, then your target is to find the best polynomial which can fit over this curve. That's the purpose of this interpolation. So there are several methods you can fit on this data. The one of the lecture that we already covered in our last is the Lagrange interpolation formula, which is available at here. You can see in this playlist is a Lagrange interpolation formula is already uploaded in this playlist. Now in this Lagrange interpolation we can find the polynomial by using Li and Yi, where Li is defined like here. Now since this polynomial is always be a unique, whatever the curve fitting you have obtained or the polynomial fitting, it is always a unique. But instead of the Lagrange interpolation, there are several other methods as well. So one of the method is called as Newton divided difference formula. So firstly, within 2 or 3 minutes, I will explain you the theory behind that, and then I will come back on the 10 examples. So what is the divided difference? If you have the data set, then assume that your function will be the linear. So what is the meaning of that? F of x is my ax plus b. Then what will be my slope? Slope is my a. A is always be a constant. So what is the meaning of that? If you have the function is linear, you may consider the function as a quadratic as well or cubic as well. We will see in the next slide. So if I consider the function as a linear, then this is nothing but the rate of change, which is always independent of the xi's. What is the meaning of that? This function is I call as the first divided difference. That is a slope of the curve. I denoted this first divided difference by f of xi xj. F of xi minus xj divided by difference. Or sometime I call as dd1. Divided difference first. Now since we can see, if I common minus from the upside and if I common minus from the denominator, then it comes to be same. So what is the meaning of that? I can say this function is nothing but xj comma xi. Fine. So what you conclude from this? It means f of xi xj is nothing but xj xi. It means the first divided difference is my symmetric. Fine. This is the first remark for you from this simple calculation. Now since the ratio is independent of the xi and xj, so I can simply take x0 and x and x1 here. I can substitute this value at here. So what is that? This comes to be this value. Can you find the value of the fx from this side? So I can multiply this over here, which comes to be. Now clearly say this is a polynomial. So which is a polynomial of degree 1. So this fx is approximated by the linear polynomial with function is my here. On the other hand, if you consider the second order degree polynomial, that means your function will be ax square plus bx plus c. Then what will be your slope? How you can find the slope? That is a derivative. So you can see which is not constant. Although what is that? This is a linear function. Fine. So if I define the slope is not a constant but it's a linear function, then we can define the divided difference 2 by using here x1, x2, x0, x1. That's the slope of the two difference, and this formula is called as the second divided difference formula. Again this formula is a symmetric, so we can write like here. So this is the point with respect to that quadratic. So we have the three coordinates x0, x1 and x2. Since again it is independent of x, again this is the symmetric. Fine, you can easily verify that. So since it is independent of this, I can open this values like of this formula. Can you find the value of f of x0 and x, which is to be here? Again by using the first divided difference, I can open this value. which comes to be here by using the first divided difference, and again you can find the value of the fx by simple calculation. So which is nothing but the second degree polynomial. Now you can see that what you obtain, this is the x0, the first value is x minus x0, second value is x1, so x minus x0, x minus x1 into first divided difference second. So in general, if you find the kth, you will get as x minus x0, x minus x0, x minus x1, and then so on up to the kth. Or you can also write like this way, x minus x0 first divided difference, second divided difference, and so on. Because it's not an easy task for you to remember this formula, so I will tell you a simple way how you can remember this formula. So look at it. I will explain you with the help of this example. Your first step is always to construct this table called as the divided difference table. How you can construct? First divided difference, subtract them. 100 minus 48 divided by subtract of this. So what is the answer of this? You can find this, you will get 52. Then you have to write this number in between this position. Fine. Now you have to find this one, same, 294 minus 100 divided by 7 minus 5. You have to write the calculation in between them. So you have to write it. Similarly for this case, it is my 900 minus 294 divided by 10 minus 7. Same for this, same for this. Always write in between them. Fine. So once you can write this, so because this is the first example, I have to write again each term again. Otherwise you can write it directly by using the calculation. Now for the second divided difference, again we can use here 97 minus 52 divide. Now it's a second difference, so we can start with the second difference, 7 and 4, x0, x2. So after the calculation you will get as 50. Now this number you can write in between them. Then after that you can use this number, 202 minus 97 divided by this minus this, 10 minus 5. So you can find this number as here. Similarly for another one, 310 minus 2 subtraction of this. The next one is 13 and 10. Fine. So you can write as here. Similarly, you can find this divided difference. You can formulate the table until you will get as a 0. All numbers are 0. All numbers are my constant. So this number will be 21 minus 15. Now it's a third. You start from here and the third number. Third is my this one. So 10 minus 4. Another is 27 minus 21 divided by 5 and 11. And the last number is this number, 33 minus 27, 7 and 30. Fine. So you have to write the calculation in between these numbers. Fine. Now you can see it's a constant series, so there is no need to find the fourth divided difference because we get a constant series. Now how you can find the polynomial? That's very simple. You can pick always about the first parts. Fine. The first number you can write as such, plus this number 52 into x minus first number, plus this is my 15. This is my second difference, so you have to take the two numbers, x minus 4, x minus 5, plus this number is 1. This is my third, so you have to write the first three numbers, x minus 4, x minus 5, x minus 7. So this is my here. So if you open this bracket, you will get this as a required polynomial. Otherwise there is no need to find, because we need to find the value of f of 8. You can substitute x is my 8 here. You will get the required answer as this one. So this is a simple way. Now we will see the rest of the examples in a very simple manner. So given data set is given, you have to find the polynomial and the point. So can you find the first difference? So it is minus 4 minus 3 divided by 0 minus minus plus. So it will be my minus 7 right in between them. Next number will be 5 minus minus plus 4 divided by this number 1 minus 0 is 9. Next number will be here minus 6 minus 5 divided by 2 minus 1. it is minus 11. So you will get, always remember you have to write in between them. Now it's a second difference, you have to subtract this number. It is 9 minus minus plus 7 divided by this second 1 plus 1. 16 divided by 2, 8. Next number is minus 11 minus 9, subtract this and this, leave the 1 1. So 2 minus 0 is a 20 by 2 is minus 10. So since they are not constant and they are not 0, so we can find the third one. So we can use this minus 10 minus 8. Now it's a third, so you can start from here and the third one from this. So 2 minus minus plus 18 divided by 3, it's minus 6. Now since it's a constant number, it's a single number, we can write as polynomial. So we can start from here, this, this and this. So what is that? It's my f of x will be 3 plus first number will be minus 7. So it's a plus minus minus. It's a minus 7 of the first divided difference. So you can start from here. X minus minus plus 1. It's plus 8. It's a second difference. So I can take as the two numbers. X plus 1 and x minus 0. Minus 6. It's a 3 number. X plus 1, x minus 0, x minus 2. This is the required polynomial of here. Because we use the 3 divided difference, that's why P3. If you open this bracket, you will get the required polynomial. Now, your target is to find the f1.5. You can substitute the value of 1.5 here, here and here. You will get this as the required answer. Now you can see fit the lowest polynomial of degree which takes this value here. So this is the value of y is equal to f of x when x is my here. So you have to write firstly x and fx here. So either you can start with like here, x value is my 3, 2, 1, minus 1. Corresponding 3, x is my here, this way. Or you can write, for the calculation sake, you can write the smallest value firstly, x is minus 1, 1, 2, 3. The corresponding value of the fx, when x is minus 1, the value of the fx is minus 21. Then it's a 15 and then so on. So you will get this expression. Now you can find the divided difference firstly, 15 plus 21 divided by 1 plus 1. So it is my 36 by 2. It's 18. Always write in between them. Then look about this, 12 minus 15 divided by 2 minus 1 minus 3. 3 minus 12 divided by 3 minus 2 is a minus 9. Now since they are not constant, so we can find the another one. So this is number is minus 3 minus 18. It's a second divided difference, so you can start from 1, 1 and 2, this number. So 2 minus minus plus 1. So 21 by 3 minus 7. Then look about these numbers. Minus 3 minus minus plus 3, 1 and 3. So it's a minus 6 by 2 is minus 3. Since again they are not constant, then we can find the another number. Minus 3 plus 7 divided by, because it's a third difference, we can start from the third, 1, 2, 3. We can start from here. So 3 minus minus plus 1. So it's a 1. Always write in between them. Now since it's a constant number, so there is no need to find the fourth number. So how you can start this? 21, 18, 7, 1. So we can write here minus 21 first number. 18 is a first divided difference. We can write as a first number only. Minus 7 is a second. So we can write as a two numbers. 1 as a 3. So we can write as a first three numbers here. So now you can open this bracket. You have to find the required polynomial is my answer. So if somebody wants asked to find the value of the f of 4, you can substitute f of 4 either at this or at this equation. Okay, look at this another one. You have to find the divided difference formula. We have already solved the same example in the Lagrange interpolation formula. But in this case, we have to find the divided difference. We can make a table. Starting value, lowest values here and we can find this table 2.8182 minus 2.8156, that is the difference of this, minus 658 654. So once you can get, you will get at this one. Next one you can subtract here and this, you will get this. Similarly for the third. After that you can subtract these numbers, 0.00070 minus 0.00065. So since it's a second divided difference, start from the first and the 1 second. So 659 654. Similarly, once you take this, then you have to take this and this. So you can write in between them. Since they are not constant, so we can find this another one, third divided difference, this number and this number you can get as here. Then you can find the polynomial f of x by using the upper values of the each of this divided difference. The first number, this number is my first difference, so I can written only as my here. This is my second divided difference, so I can taken as a 2 number. This is my third difference, so I can taken as a 3 numbers here. Now your target is to find the values at x is equal to 656, because my f of x is log of 10 of x. So now my target is to find the value of 656. I can substitute this value in this expression. We can get the value as here is the requirements. Look at the another one. Again, our first target is to make a table. Now I think you can easily make a table. 5 minus 1 over 2 minus 1. So it is my 4 and so on. Then you can find the second divided difference, which comes to be here. You can find the third divided difference, 1 by 6 minus minus plus. It's a 1 and 8. So after the calculation you will get as this number. Since it is a constant number, a single number, there is no need to find the fourth one. Then based on this number you can write as the sequence. And your target is to find the value of the f of 6. So you can substitute x is my 6 in this expression. So you will get right answer as here. Look at the another one. Again you have to fit the polynomial. So we can write the smallest number to the largest number. How you can find this number again? It's a 33, 1, 2, 4, 5. Subtraction of this, minus 1, minus minus plus 4. You can get here. Similarly for this, this and this. Since this is not a constant number, so we can find the another sequence which comes to be here. Again they are not constant. We can start from here. 10 minus 94 is a third divided difference. So first number and the third number, 2 plus 4, this comes to be here. And this is 88 minus 10, it's a 5 minus minus plus 1, which comes to be this one. Now since these are not constant number and not a 0, so we can find the another number, 13 plus 14, 13 plus 14 of the fourth divided difference. First number, 1, 2, 3, 4. So 5 plus 4, which comes to be 3 is the here. Then we can take again the upper values and we can find the formulation of polynomial. After the calculation you can open this bracket, you will get as the required polynomial as here. You can also check your answer at any time, because you can see when x is 0, you can see what is the f of 0, you can see 5 satisfied. You can substitute f of minus 1, it comes to be 33. So you can see it's a 3 plus 5 plus 6 plus 14 plus 5. If you solve them, it comes to be 33. Similarly, you can take any value, you will get the verification of your answer in your examination. This is another category. Again you have to find the polynomial, but in the power of x minus 5. Fine. In all those previous questions you have to find a single polynomial here. But now we want to be a polynomial which comes to be like a0 x minus 5 of power something, a1 x minus 5 of power something, and so on. Very simple. We can firstly proceed to the divided difference. We can formulate this. Let's say 26 over 2 minus 0. This is 58 minus 26 over 3 minus 2, and so on. You compute it here. Then this comes to be 32 minus 11, second divided difference, 3 minus 0, which comes to be here, which is not a constant number. We can find the next number, 11 minus 7, it's a third divided difference, 1, 2, 3. 4 minus 0, it's come to be 1. Now you can see this is a constant number, so there is no need to find the fourth one. Then we can take the first value of each table, we can formulate this polynomial. I can open this bracket, which comes to be here. But this is not the required answer, because our target is to make each number as here. So what is that? How you can do? The first way is, I can write this. So what I can do? I have to minus 125. I can add 125 here. It's a 3a square b. So I have, it's minus 15x. So I have to add a 15x and so on. But it will take a lot of time. After that you write this part also, 2 times x minus 5. Then you have to subtract, and that's not an easy target. So our target is to express this in here. Now I will tell you the second method. First method is you can express each terms in here. Second is you can take this polynomial x cube plus 2x square plus 3x plus 4. You can divide this by x minus 5. After that you will get some numerator, quotient and the remainder. But that will again take a very lengthy calculation. So I will use this simple method. What can do? Use this expression, take the coefficient of the x cube. The first number is the coefficient of the x cube. This number is coefficient of the x square. This number is coefficient of the x. This number is coefficient of the constant. Fine. So if my expression will be like here, x cube plus 5x square minus 4. So there is no coefficient of x. I have to put here as a 0. Fine. But anyhow, now in this case it is my this number. Now my target is to express in terms of the 5. So I can firstly find the value of the x from here. This comes to be 5. So I have written here as a 5. If somebody will ask you find this in terms of the x plus 1. So that means you can substitute this number as a 0. It's a minus 1. So instead of 5 you can write here as a minus 1. Now rest of the target is very, very simple. What you can do is you can write here. First number you can write as such. Multiply this by here. 5 into 1, 5 you can write here. 5 plus 2, 7. 5 into 7, write here, 35. Add them, 38. Multiply them, 190. Fine, you can 194. Clear? If somebody asks you write in terms of the x minus x plus 1, then you have to start from here, coefficient of this by minus 1. Write 1 here. Multiply this, minus 1, add them, again minus 1, it is my 2, multiply them, minus of 2, it is my 2. Or any of the number you have to given. Now you will get here. Now since again, until you will get a constant number or the same series, again you write a 5. So again you can write as a first number as a 1, multiply them 5, it's a 12, it's a 60, is come to be 98. Fine. Again, because these two numbers are not constant, so we can write again as here. First number is 5, 1, 5. Because this last number you can skip that. Fine. This is my 70. This is the last number, you can skip them. So which comes to be here. Then again, you can write here. Because this I skip them, so there is only a single number. That's a constant. So therefore, my required polynomial will be start from here 1 coefficient of x cube, so x minus 5 cube plus whatever the number here 17 x minus 5 square is a plus 98 x minus 5 cube 3 and this is my constant number is the required polynomial of this in terms of x minus 5. Otherwise, whatever the expression given to you, somebody may ask you, you can find in terms of 2x plus 7. What you can do? X will be minus 7 by. So instead of this, you can write as a minus 7 by 2 and so on. So that's the simplest way you can solve. Okay, look at one more example. Again, you have to, now you can see, it is not given that you have to apply the Newton divided difference, or you can apply either as a Lagrange interpolation. Since nothing is given, you may apply the Lagrange interpolation or the divided difference. So since this lecture is the divided difference, so I can solve this problem by the divided difference. So you can easily formulate this. Like I can show you again this value. So it will be my 2 plus 0.25 divided by here. So it comes to be 2.25 divided by 1.5 is to be here. Since the last number is my constant, so there is no need to find the third divided difference. So you can use this. You can use these numbers and then you can make as table. The first number is my minus 1.5 of the first divided difference, x minus this. 1 is the second divided difference, so you can write here. Then finally you have to find the value at point 4. Substitute the x is equal to 4. You will get answer as 6 is the required answer. We will see the next lecture on the Newton's forward divided difference formula. We will solve the various examples in these lectures. Till then, you can simply like, share and comment on my video. Best of luck students. Happy learning.